Let's see what is a charge on electron by the Milikan's method. In 1909, R.A. Milikan devised a technique that resulted in a precise measurement of the charge on an electron. A schematic diagram of the Milikan oil drop experiment is shown in figure 12.2.3a, and two parallel plates P prime are placed inside a container C to avoid disturbance due to air currents. Separation between the plate is D. The upper plate P has a small hole H as shown in the figure. The voltage V is applied to the plates due to which the electric field E is set up between the plates. The magnitude of its value is E, which is equals to V upon D. An atomizer A is used for spraying oil droplets into the container through a nozzle. The oil drop gets charged because of the friction between walls of the atomizer and oil drops. These oil drops are very small and actually in the form of mist. Some of these drops happen to pass through the hole in the upper plate. The space between the plate is illuminated by the light coming from the source S through the lens L and window W1. The path of the motion of these drops can be carefully observed by a microscope M. A given droplet between the two plates could be suspended in air if the gravitational force mg, F is equals to mg acting on the drop is equal to the electrical force F is equals to QE as shown in the figure 12.2.3b. The Fe can be adjusted equal to the Fg by adjusting the voltage. In the case, we can write Fe is equal to Fg, Q is equals to mg. If the value V is the value of the PD and between the plates for this setting, then E is equals to V upon D, and we may write Q V upon D is equals to mg, Q is equal to mg D upon V. In order to determine the mass of the M droplet, the electric field within the plates is switched off. The droplets fall under the action of gravity through their terminals. A terminal speed of Vt almost at the instant the electric field is switched off. Its terminal speed Vt is determined by the timing the fall of the drop over a measured distance. Since the drag force F due to air acting upon the droplet when it is falling with constant terminal speed is equal to its weight. Hence, using the Stokes law, F is equal to 6 pi eta r Vt gives us equals to mg, where r is the radius of the droplet and n eta is the coefficient of viscosity of air. If rho is the density of the droplet, then m is equals to 4 upon 3 pi r cube rho, 4 upon 3 pi r cube rho g is equals to 6 pi into r Vt, and r square is equals to n eta Vt upon 2 rho g. Knowing the value of r, the mass m can be calculated by using equation 12.5. The value of m is substituted in equation 12.44 to get the value of charge q in the droplet. Milikan measured the charge on many droplets and found that each charge was an integral multiple of a minimum value of charge equal to 1.6 into 10 raised to power 19 coulomb. He therefore concluded that this minimum value of the charge is charge on an electron.